This is topic 6-1, solving equations with variables on both sides. Our objective today is I can solve equations with variables on both sides. To take that objective and turn it to a central question, we're just going to change it to how can I? So how can I solve equations with variables on both sides? By the end of this lesson, you should be able to answer that question, and we will when you fill in your summary. Today's bell work is a review problem. Mr. Smith called Drano Plumbing Company to fix a leak. Their fee is $45 for the service call and $32 per hour. We're going to use our table and then write an equation and then write and solve the equation to find out how long they worked if her bill was $205. That should be his bill was $205. So let's first start with our table. We have hours in our first column, and our last column is going to be how much it cost. In the middle is where we're going to put our process. Our process, we always put, hey, we're going to begin, then we are going to add or subtract based upon how it changes, and the change is times the input. Remember that our input is our X column, or our first column, and our output is our Y column, or our last column. So let's find out. At 0 hours, that means the plumber has worked 0 hours. How much are we going to be charged? It says that our fee is $45 for the service call and then $32 per hour. Since I'm not working any hours, this tells me I will be charged $45 just to call. After 1 hour, I'm still charged that $45 I have to pay, but now there's 1 hour, and so I'm going to add to it, and for 1 hour, it is $32 for that 1 hour. My total cost is $77. After 2 hours, I have 45 plus 32 times 2. Or I can take my 77 that I got and say, hey, it's going to work another hour, so I'm going to add another $32, and my total is going to be 109. So my table then can help me figure out what the equation is, or I can just look at the information given and figure out what the equation is. Part B says we're going to write that equation, determine the amount she would pay for C for H hours. So determine the amount, I said that should be a he. He would pay C for H hours. When they ask us this question, remember the first letter is our output, the second letter is our input. So if I look at my output, that's my cost. C is equal to. I can go back to my process where it says beginning plus or minus the change times the input. Or I can look at the information that's given. I know my cost is going to be $45 for the call. Then I know the and tells me I'm going to add to it plus $32 per hour. I can recall from my vocabulary per means multiply, and I'm going to multiply by what follows, which is hours. So this tells me it's going to be 32H. This does match what I have in my second column of the process. Part C says write and solve an equation to find out how long they worked if their bill was $205. To find out, we have to recognize that $205 is a cost. So in my equation where I see the letter C, I'm going to replace it with 205. That's equal to 45 plus 32H. The solution then is to actually figure out what H is equal to. Some of you will continue to do your table and say, hey, after 3 hours, if I add another $32, this will be $141. In 4 hours, I add another $32, and this will be $173, and continue on that way. Others, however, will choose to, hey, let's solve it. This is an equation I know how to solve. So we'll solve, draw our line down the equal sign, box in the term with the variable, get rid of the term that's not in the box, but it's on the same side. That's the 45. We do the opposite, so it'll be minus 45. 205 minus 45. It's 160. It's going to be equal to 45 minus 45 is 0. and then a positive 32h that is still in my box. I want h by itself, so I got to get rid of the 32. It is multiplied by 32, so I'm going to divide by 32. This will give us h is equal to 5. H is equal to 5. H represents hours, so this will be 5 hours. It takes 5 hours for the bill to cost $205. Now we are going to go on to our lesson for today. Before we start, it's a good time to pause the video and see if you can find the solving equations flowchart that you have used before. Some of you may have it in a spiral, some may have to just print it out again. So at this time, if you need to, pause and find your flowchart. Now that you found your flowchart, we have been dealing with equations that have dealt with all the steps except for step number 4. Because step number 4 is what we have. Do you have variables on both sides of the equal sign? Up until this point, we have not had that. So I want you to find step 4 on your flowchart. In the past, we've always answered no and just gone on down. But now we're dealing with yes. It tells us to do the opposite of the smaller coefficient. I want to change this because if I do the opposite of the smaller coefficient, I'm going to be working on both sides of the equation at various times. So I want us to change this. We're going to cross through this. And we're going to move the variable on the right side. And we want to move it to the left side. And the way that we move it is we're going to do the opposite of the coefficient. Another thing I like to say is that if you cross the line, we change the sign. So when we move the variable on the right to the left side, we're going to do the opposite of the coefficient, which means we're either going to add or subtract. We'll go ahead and add that in there. Add or subtract. And the way that you know if you're adding or subtracting is that if you cross the line, you change the sign. So we're going to do a couple of examples to see how that works. Our first example, we have the equation 5x plus 3 equals 3x minus 5. Sorry, 3x minus 7. So I'm going to bring up my flow chart. We're going to follow the flow chart. First thing we do is draw the line down the equal sign. Do we have parentheses? No, there's no parentheses. Can you combine like terms on each side of the equal sign? So if I look at just the right-hand side of my equal sign, there are no terms that I can combine. 5x plus 3 cannot combine. If I look at my left side of the equal sign, there's 3x minus 7. There's nothing that I can combine. Step 4 says, do you have variables on both sides of the equal sign? I like to use a highlighter in order to highlight my variables, and so I can see that yes, I do have variables on both sides of the equal sign. So now I'm going to move the variable that's on the right side to the left side by doing the opposite of its coefficient. My variable that's on the right side is the 3x. To do the opposite of its coefficient, I am going to subtract 3x. So notice how this also follows my little saying of if I cross the line, I change the sign. I'm moving the 3x to the left, so I cross this line, my equal sign. That means I need to change the sign to a minus 3. 5x minus 3x is 2x. We'll drop the plus 3 down because we didn't do anything with it. 3x minus 3x equals 0. That's what we want. So 0 minus 7 still gives us a negative 7. Now we're on step 5. It says box the term with the variable. This should sound very familiar. Step 6, do the opposite of the term not in the box. The 3 is the term that's not in the box. It's on the same side, so the opposite would be minus 3. We still have a 2x in the box. 3 minus 3 is 0. It's gone. Negative 7 minus 3 is a negative 10. Last step says do the opposite of the coefficient in the box. So I need to get rid of the coefficient that's in the box. That's the 2. It's being multiplied by x, so the opposite is divide by x. And notice I do not change the sign of this 2 because it's in the box. I cannot change the sign. The 2's will cancel. On the left, we're left with x. Negative 10 divided by 2 is a negative 5. So our answer is x equals negative 5. We're going to apply this same process to our other side now. Draw a line down the equal sign. Do we have parentheses? No. Can you combine like terms? No. Do we have variables on both sides of the equation? I have a negative 2a on the left and a positive 3a on the right. So now we are going to move the variable that's on the right to the left by doing the opposite of the coefficient. That means it's a positive 3. I want to move it, positive 3a, I want to move it to the other side so it becomes a negative 3a. I still, whatever I do to one side, I do to the other. So I crossed the line, the 3a crossed the line, it changed its sign. 16, nothing happened to it, it drops down. Negative 2a minus 3a is a negative 5a equals 2. 3a minus 3a, that is 0. 0 minus 4 is a negative 4. Step 5 says to box the variable with its term. That's a negative 5a. Step 6, do the opposite of the term that's not in the box. That's the 16. The opposite is negative 16. 16 minus 16 is 0. Negative 5a is still in the box. And then negative 4 minus 16 is a negative 20. The last step, do the opposite of the coefficient in the box. That's a negative 5. It's being multiplied by a, so the opposite would be to divide by. And we're going to divide by the coefficient. We divide by a negative 5. Negative 5 divided by negative 5 leaves us with a, and negative 20 divided by negative 5 is a positive 4. So our final answer is a equals positive 4. Problem 3. Let me get my flow chart again. We're following our steps again. Draw a line down the equal sign. Do we have parentheses? Nope. Can you combine like terms on each side of the equal sign? No. Do you have variables on both sides of the equal sign? Yes, I do. Let's highlight them. It's a negative k and a positive 5k. The 5k is on the right, so we want to move the variable that's on the right to the left. I cross the line. I change the sign. This becomes a negative 5k. I didn't do anything to the negative 15. It drops down. Negative k minus 5k. With the negative k, there's an understood 1, so this becomes a negative 6k. Positive 5k minus k is 0. We're still left with 0 plus 3 is 3. Now we will box our term with the variable. That's a negative 6k. Do the opposite of the term not in the box. That'll be a positive 15. Negative 15 plus positive 15 is 0. We still have a negative 6k inside our box. And then 3 plus 15 is 18. The last is do the opposite of the coefficient in the box. That's the negative 6 times k. The opposite it would be divided by. And we're going to divide by the number in the box. So we divide by negative 6. Negative 6 disappears. We have k equals 18 divided by negative 6 is a negative 3. Number 4. Following our same steps, we draw a line down the equal sign. No parentheses. Step 3, we cannot combine terms. We move to step 4. Do we have variables? Yes, we have a 2y and a negative y. Step 5, we're going to box our variable. Nope, I'm sorry. Step 4, yes, we have variables on the both sides. So now we need to move the variable from the right to the left. I have a negative y on the right. I want to move it to the left. It will become a positive y. There's an understood 1. So 2y plus 1y gives us 3y. The plus 8 drops down. Negative y plus a positive y equals 0. 0 plus 8 leaves us with 8. Now we're back to solving. Box our variable. Get rid of the number not in the box. Subtracting 8 from both sides leaves us with 3y in the box still. Positive 8 minus 8 is 0. Positive 8 minus 8 is 0 on the right-hand side also. Last step, get rid of the number in the box. Is being multiplied by y. 3 is being multiplied by y, so we have to divide by the coefficient of 3. Our 3's disappear. We're left with y equals, and 0 divided by 3 is 0. So y is equal to 0. Our next problems are combining what we've done in the past. Meaning it's just a review. Let's write an equation, and then we're going to actually solve. Every time we see a number, we can use a variable, and we're going to use the variable x to represent a number. So a number minus is the minus, 2 is means equal, and then 8. So our equation is x minus 2 equals 8. To find a solution, we solve. Draw a line. There are no parentheses. We cannot combine terms, and we only have variables on one side, so we're going to box our variable. Get rid of the number not in the box. We'll add 2 to both sides. We are left with x, and 8 plus 2 is 10. So our solution is our number is equal to 10. Problem 6. 7 more than 25% of a number is 13. More than means plus, and it is also a switch word. That means the number that it's in front now goes to the back. And what comes after more than goes into the front. So I need to show 25% of a number because I know is equal, and we'll end up with 13. 25% of a number, so 25% of anything means I'm going to multiply. I need to change the 25% to a decimal. Some of you will remember 25% is 25 over 100, and that is 0.25. Others will remember if I have a decimal after the 5, I'm moving it 2 spaces to the left. So we're going to get 0.25 of a number means times a number x, more than, so more than gives us the 7, the plus, and then the 7 follows afterwards, is 13. Now we can solve. Draw a line down the equal sign. No parentheses, no terms to combine, and we only have a variable on one side, so we can box the term with the variable. Get rid of the number not in the box, subtract 7 from both sides. We're left with 0.25x in the box. 7 minus 7 is 0, and then 13 minus 7 is 6. Last, we want to get rid of the number in the box. So 0.25 is being multiplied by x. We're going to divide by the number that's in the box. Divide by 0.25. 0.25's disappear on the left. We're left with x, and 6 divided by 0.25 is 24. So our number is 24. Number 7, we have 2 less than 3 times a number is 28. Less than is a minus. It is also a switch word. So I know I have a minus sign. The 2 now goes behind the minus sign. 3 times a number, does be 3 times x, tells me equal, and then 28 is what follows. To solve it, we draw a line down the equal sign. Box our term with the variable. Get rid of the term that's not in the box, so that'll be a plus 2. We have 3x in our box. Negative 2 plus 2 is 0. 28 plus 2 is 30. To get x by itself, we're going to divide by the number in the box, and x is equal to 10. Our solution then is the number is equal to 10. Our final thing to do is to determine our summary. Our summary is answering that question that we wrote. And the question that we wrote was, how can I solve equations with variables on both sides? So I just want to answer that question rather than going through all the steps of solving equations. What in particular did we do in order to solve equations with variables on both sides? So the answer is, when we have variables on both sides, when we have equations with variables on both sides, question is, what did we do? Okay. We moved the variable on the right side, and we moved it to the left side. And the way we did that was by doing the opposite of the coefficient. Notice I am taking advantage and using my shorthand. So again, in summary, when we have an equation with variables on both sides, we move the variable on the right side to the left side by doing the opposite of the coefficient. You could add more in there. You could talk about how when you cross the line, you change the sign. You could also talk about the fact that we used a highlighter to highlight the variables to let us know we had them on both sides, but this would be the minimum. That concludes our topic for today, topic 6-1, solving equations with variables on both sides.